On page number 16 of your textbook, you have this table. You can see there are some type of examples given here, students, and you can see that these equations are not linear, but the above equations can be made linear or they can be converted into the linear equations. To do this, we are going to use a proper variable and make a change in the above equations or in the given equations. Substituting the new variables in the given nonlinear equations will help us convert them into linear equations. Let us take a look at the flowchart given on page number 19. Activity. Example, 5 upon x minus 1 plus 1 upon y minus 2 is equal to 2 is one given equation. 6 upon x minus 1 minus 3 upon y minus 2 is equal to 1 is the second equation. As you can see, 5 upon x minus 1 can be written as 5 into 1 upon x minus 1. You can see in both the equations x minus 1, y minus 2, y minus 2. So we can replace x minus 1 and y minus 2 by suitable variables. Let's replace them considering 1 upon x minus 1 by m and 1 upon y minus 2 by n. After substitution, you will get two more new equations. Further, after solving these two equations, we'll get the value of m and n. But you can very clearly see the equation is in form of x and y. So further, we have to resubstitute. That is replacing m and n by their original values. What is the original value? M is equal to 1 upon x minus 1 and n is equal to 1 upon y minus 2. So, after replacing 1 upon x minus 1 is equal to 1 upon 3 and 1 upon y minus 2 is equal to n, we will get the values of x and y. And this values of x and y is the solution of the given simultaneous equations. So, to solve such type of equations which are not linear, we have to follow the steps in order that we can find out the solution for the given equations. Let us now begin with practice set 1.4. The second sum from set 1.4, 10 upon x plus y plus 2 upon x minus y is equal to 4. Call it as equation number 1. 15 upon x plus y minus 5 upon x minus y is equal to minus 2. Equation number 2. Now, the first step is replacing x plus y and x minus y. As you can see, x plus y in both the equations and x minus y in both the equations. So, let us replace. Let 1 upon x plus y is equal to m and 1 upon x minus y is equal to n. 10 x plus y can be written as 10 into 1 upon x plus y, 2 into 1 upon x minus y, 15 into 1 upon x plus y and minus 5 into 1 upon x minus y. So let's replace them now. So the first equation will get converted into a linear equation. 10 into 1 upon x plus y is equal to m. So the equation will be 10m plus 2 1 upon x minus y is n. So it will be 10m plus 2n is equal to 4. And the second equation, 15 into 1 upon x plus y. 1 upon x plus y is equal to n. So 1 upon x plus y is equal to m. So 15m minus 5 into 1 upon x minus y. 1 upon x minus y is equal to n. So minus 5n is equal to minus 2. So the two new equations are 10m plus 2n is equal to 4 and 15m minus 5n is equal to minus 2. I hope you must have understood the replacing part, children. This is the first step of solving the sum. Now let's go to the next step. You can see coefficient of m and coefficient of m here are different, and at the same time coefficient of n is also different. So we need to equate the coefficients in order we can eliminate any one variable. For doing so, you can either equate the variable of m or you can equate the variable of n. Let's do this. Equation 3 multiply by 5 and equation 4 you can multiply it by 2. That means I've selected 2n and n. n coefficients. So once again I'm multiplying equation 3 by 5 and I'm multiplying equation 4 by 2. Let's do it. 5 tens are 50m, 5 into 2 10n, and 5 fours are 20. So we get a new equation, equation number 5. Let's go on to the next side. Multiplying equation 4 by 2, 15 twos are 30m, minus 5 into 2 minus 10n, and minus 2 into 2 minus 4. So the new equation is 30m minus 10n is equal to minus 4. That is equation number 6. Now if you compare equation number 5 and equation number 6, you will see 10n and minus 10n. Just adding this two equation will help us cancel 10n and 10n so that we get the value of m. So we have eliminated one variable. So just adding equation 5 and 6. Equation 5, 50m plus 10n is equal to 20 and 30m minus 10n is equal to minus 4. Just adding them. So plus 10n minus 10n will get cancelled. You get 80m is equal to 20 minus 4, 16. So m is equal to 16 upon 80. So the value of m is equal to 1 upon 5. Now substitute m is equal to 1 upon 5 in equation number 3. You can take equation number 3 or you can take equation number 4 and or any other equation. Let's substitute. So we have taken equation number 3, 10m plus 2n is equal to 4. 10 into m is 1 upon 5. So we are substituting the value of m as 1 upon 5 plus 2n is equal to 4. Now after solving, 5 ones are, 5 twos are, we'll get 2 plus 2n is equal to 4. So 2n is equal to 4. Plus y and minus y. So you can cancel them. So just add equation 7 and 8. X plus y is equal to 5 and x minus y is equal to 1. So plus y minus y will get cancelled. 2x is equal to 6. So x is equal to 6 upon 2. So you get the value of x as 3. Now substitute x is equal to 3 in equation number 7. Equation number 7 or 8, you can take any one equation. X plus y is equal to 5, 7 or x minus y is equal to 1, equation number 8. So you're going to substitute x is equal to 3 in equation number 7. 3 plus y is equal to 5. So y is equal to 5 minus 3. So you get the value of y as 2. So the solution set x comma y is equal to 3 comma 2. Let us now do the third sum from the same exercise. 27 upon x minus 2 plus 31 upon y plus 3 is equal to 85. Equation number 1. 31 upon x minus 2 plus 27 upon y plus 3 is equal to 89. Equation number 2. So the first step is replacing 1 upon x minus 2 and 1 upon y plus 3. So we are going to take, let 1 upon x minus 2 be equal to, say, m or a. Let's take a. And 1 upon y plus 3 is equal to b. So the first step is, let assuming 1 upon x minus 2 as a and 1 upon y plus 3 is equal to b. Let us now form new equations after substitution. So 27 into 1 upon x minus 2, 31 into 1 upon y plus 3, 31 into 1 upon x minus 2 and 27 into 1 upon y plus 3. So the equation can be written as 27 into 1 upon x minus 2. 1 upon x minus 2 is a. So 27a plus 31 into 1 upon y plus 3. 1 upon y plus 3 is 31b is equal to 85. Let us call this as equation number 3. Move on to the next side. 31 into 1 upon x minus 2 is a. So it will become 31a plus 27 1 upon y plus 3 is b. So 27b is equal to 89. So we get this as equation number 4. Now you can clearly see, students, coefficient of a is coefficient of b and coefficient of b is coefficient of a in both the equations. So we know the method of solving such type of equations, and we do it by adding both the equations and subtracting the equations. So the first step is, let us add equation 3 and 4. So 27a plus 31b is equal to 85 and 31a plus 27b is equal to 89. So we are just going to add them. After adding, we see the total will be 7 plus 1, 8, 5, 58a plus 58b is equal to 174. If you divide the equation throughout by 58, so dividing by 58, we get a plus b is equal to 58, 3s are 174. So we'll call this as equation number 5. Now let's get back to equation 3 and 4. We are going to subtract equation 3 from 4. So let's do it. Subtract equation 3 from 4. So let's write equation number 4. 31a plus 27b is equal to 89, and equation 3, 27a plus 31b is equal to 85. Subtract. The signs will change. Minus plus minus, minus plus minus. So let's do it now. 31 minus 27 will be 4a, minus 31 plus 27 will be minus 4b, and 89 minus 85 will be equal to 4. So here also, students, we can see throughout the equation we can divide by 4. So when we divide the equation by 4, we get a minus b is equal to 1. Let's call this as equation number 6. The next step is finding the values of a and b. So you can see in equation number 5 and equation number 6, plus b and minus b. So as we add equation 5 and 6, a plus b is equal to 3 and a minus b is equal to 1. So we are just going to add. Plus b minus b will get cancelled. So 2a is equal to 4. So a is equal to 4 upon 2. So the value of a is equal to 2 ones are 2 twos. The value of a is 2. Now let's select equation number 5 and substitute the value of a. A plus b is equal to 3. So 2 plus b is equal to 3. So b is equal to 3 minus 2. So b is equal to 1. We have reached till finding the values of a and b. Now the next step is resubstituting. A is equal to 1 upon x minus 2, which is equal to 2, and b is equal to 1 upon y plus 3, which is equal to 1. Let's do it. So 1 upon x minus 2 is equal to 2, and 1 upon y plus 3 is equal to comma y, which is equal to 5 upon 2 comma minus 2. With the help of these examples, you can continue solving the remaining sums from practice set 1.4.